All right, so the metabolism of a toxic agent. This is a high-level explanation. In phase one, so let's start with the xenobiotic. Xenobiotic going to the metabolite. In phase one, it can undergo oxidation, cytochrome P450 oxidation, reduction, and hydrolysis. It can form a metabolite. Now, these are some of the active elements that are affected in phase one metabolism. You may have something that is carboxylated, gets hydroxylated, sulfur groups, and so forth. The addition of, in phase one, oxidation, reduction, or hydrolysis, in phase one, the effect on the xenobiotic is minimal. So it does make the xenobiotic slightly more water soluble. And when something becomes slightly more water soluble, it's more easily excreted, but it's going to be a modest change. Now, having said that, phase one metabolism can have two effects. It can make a metabolite more water soluble, more hydrophilic, water loving, or it can actually cause that molecule to become activated. During this activation, that molecule, let's say the xenobiotic was pretty neutral in terms of its reactivity with the body, it could get activated in phase one. And so while it might become more water soluble, it might also become more reactive. We're going to say more about that in a moment. The other thing that can happen to the metabolite prior to it going through excretion, it can actually enter the phase two metabolism pathway. It can get conjugated. So a xenobiotic can be directly conjugated, or the metabolite from phase one can become conjugated. In either case, whether it is the xenobiotic itself or the metabolite from the xenobiotic, if it goes to phase two, it will become conjugated. And we're going to talk quite a lot about this as we go forward. So I'm not going to spend too much time right here, except to say, remember that phase one, modest modifications. They're going to be cytochrome P450 mediated. They can be oxidated, they can be reduced or hydrolyzed. In phase two, we're talking about conjugation reaction, and these include glucuronidation, sulfonation, methylation, acetylation, amino acid conjugation, and glutathione conjugation. That may sound like a lot, but we're going to get into that and clear this all up. Now, the stable conjugate becomes much more water soluble and can be excreted. It can also become a non-polar species, so that in doing this is what enhances the greater excretion of that molecule. All right, so in review, phase one reactions modify the chemical substrate, generally a hydrophobic compound, by adding a chemically functional structure. In phase two transformation reactions, these include glucuronidation, sulfonation, acetylation, methylation, conjugation with glutathione, which can result in an increased hydrophilicity and facilitates excretion. This modification results in a new substrate for the phase two enzyme to react. The phase two covalently tags, so this is a covalent change, the new substrate with another substance that is usually hydrophilic. So I like this text because it's saying that it is tagging that chemical moiety. All conjugation reactions require ATP. So important to recognize phase one did not require ATP. Phase two conjugation reactions do require ATP. This is to either activate the xenobiotic for conjugation with glutathione or amino acids, or to synthesize high-energy cofactors. In phase two reactions, they give products that are larger molecules than the substrate and usually generally polar in nature. They become conjugated compounds, also have poor ability to cross cell membranes. And I should probably say poorer ability than the original compound. In phase 3, metabolism is further enzymatic processing of phase 2 conjugated chemicals, and it also affects transport of these chemicals through selective transport mechanisms